So let's start. Starting with the first question. Okay, and you need a data booklet for this as well. So let's open a data booklet. Now, starting with the first question, okay, explain why the atomic radius of elements in the third period decreased from Na to Cl. So remember this, when you move across the period, what happens is like Na has a total of 3 shells. It's got 2, 8, and 1. And Cl has exactly the same number of shells. Cl would be 2, 8, and 7. So apparently the atoms must have the same size, but the atomic radius decreases when you move to the right, and that is the reason behind that is that Na has fewer protons. It's positive. It's got 11 protons in its nucleus. तो ये जो बीच में ना middle में जब आप right की तरफ जाते हो, what happens is you've got more and more protons. ठीक है, तो 11 protons, इसके 17 protons. 17 protons is going to have a lot stronger attraction for electrons, which is why the size of the atom gradually decreases when you move from left to right. ठीक है, ये यहाँ पे दिया हुआ भी है, ion का size छोटा होता जा रहा है. ठीक है, when you're not the ion, sorry, the atomic radius, it's becoming smaller. So what you're going to write is that protons increase when you move to the right, while you have the same number of shells. So there is going to be stronger attraction for the outer valence electrons. Okay, that's about it. So they have the same number of shells, except that the protons keep on increasing. So there's a greater attraction for electrons. Here, uske baad hai, the radius of the most common ion of Mg is much smaller than that of the radius of the most common ion of S. Identify both ions and explain the difference in their radii. So what happens is Mg, when it forms an ion, तो वो कह रहा है कि Mg का जो ion है ना, that's smaller. Why is it smaller? Because it ends up losing its outer shell electrons. It loses its outer shell electrons, so which is why it's smaller in size. Sulfur, why is it bigger? Because when it gains electrons, it instead gains electrons. Haji. I say it ends up forming a negative ion. And when it forms a negative ion, the electrons, there's more electron-electron repulsion. So electrons repel other electrons, which is why they're further away, because you now all of a sudden have more electrons. So हमेशा याद रखना कि positive ions छोटे हो जाते हैं और negative ions जो हैं they become bigger in size, क्योंकि उनके electrons ज़्यादा हो जाते हैं, and the electrons they start repelling other electrons, which is why the size of the atom starts to increase. Next one is, you've got this reaction. Phosphorus is a non-metal in the third period, reacts vigorously with excess oxygen, but slowly with chlorine. Some reactions of phosphorus are shown. Write an equation to show the formation of compound A. So he's reacting it with an excess of oxygen. So phosphorus reacts with oxygen and ends up forming P4O10. Or you can call that P2O5 as well. Okay, that's the reaction. Give 2 observations you could make in reaction number 2. So reaction number 2, one observation is that greenish yellow chlorine gets decolorized. The other observation is that a white solid is formed. Those are the 2 observations that you're going to have in that particular case. Here, name compound B. What is compound B? When PCl5 is added to water, so hydrolysis hota hai. You can remember this. It's going to be vigorous hydrolysis. And when you have vigorous hydrolysis, it reacts with water. Two acids are formed. One of them is HCl, the other one is H3PO4. You can remember the hydrolysis of all the chlorides. Edexcel has no hydrolysis. MgCl2 has slight hydrolysis. और फिर AlCl3 के बाद strong hydrolysis शुरू हो जाता है. अच्छा, फिर next one is cerium is a lanthanoid metal that shows similar chemical reactions with some elements in the third period. Most of cerium's compounds contain C plus or C4 plus ions. Cerium shows the same structure and bonding in a typical metal, so you have to draw the structure of a typical metal. A typical metal is positive ions in a sea of free moving electrons. So you'll draw these positive ions. If there is other draw can use with me, just so this should be enough. And they're going to be delocalized electrons, so show a bunch of delocalized electrons that are freely moving around. So the next one is suggest two properties of cerium 4 oxide. It's a ceramic. Remember, what is a ceramic? A ceramic is not it's not a covalent compound or an ionic compound. It's any compound that is tough. It's resistant to heat. It's got very high melting and boiling points. So two properties अगर लिखनी है ना ceramics की, that's high melting points, and one of them would be they're very good insulators. They're not going to conduct electricity. So those are ceramics. So any compound that is kind of tough, for example, you can use it in an oven or for high power transmission, for holding cables that have high power transmission. That's a ceramic. So that is what a ceramic is. So high melting points, insulators, that's what you can write over here. And then you've got, so the two properties would be this one. The ceramics that you should know of are, you should know about SiO2. I mean, that's not the answer, but silica is ceramic. I mean, you make ovens out of clay. There's Al2O3, which is used very often in high power transmissions for holders. Like if there's a transformer, you're going to make it out of Al2O3. And there's another one, which is NGO, that's got very high, I mean, it almost has a melting point as high as diamond, around 3000 degrees centigrade. So you use it in furnaces, like really with extreme heat, nothing would happen to it. So remember those three compounds. Then you've got this reaction, all naturally occurring samples of cerium contain only 4 isotopes. Data of the 3 isotopes are shown, and the AR is also given. Use these data to calculate the relative isotopic mass of the 4th isotope in this sample. Now, first thing, always make sure you differentiate this. This 136 is the nucleon number. The nucleon number is always a whole number. But remember, the nucleon number is not usually the mass, because when you measure mass would be very close to 136, but it's not always exactly 136. Mass is something that relies, when you talk about nucleon numbers, you're counting things. When you're counting things, they're always whole numbers. But when you talk about the mass of a substance, the mass depends on accuracy. I mean, if you have a device that is very accurate, it's going to give you the mass value in decimals. So just remember that the nucleon number is, when you count things, counting things is always a whole number. But when you measure something, when you measure the mass of something or the length of something or anything, when you're trying to measure, that always comes in decimals. And it depends on the accuracy of the device. So the two values would be very close to each other, but the nucleon number is always a whole number. So anyways, your isotopic mass is 135.907, which is almost 136, because mass is in grams. And he's saying that you have to calculate what do you have to calculate? You have to calculate the isotopic mass of the fourth isotope, which is this one. So I'm going to take that as X. I don't know what that is, but I can calculate the percentage. The percentage of this thing is going to be, I'm going to subtract all the other isotopes percentages from 100, and I'm going to get this percentage. So it's going to be, so if I open a calculator, I'm going to take 100, that's the total percent, minus 88.450%, that's one of the isotopes. And I'm going to subtract 0.185% and minus 0.251. So 88.4, 0.185, and 0.251. If I subtract this, I get 11.114%. So I get this. And the AR is given. The AR is the average of the whole thing, of all the isotopes. How do you calculate the average of all the isotopes? What you do is, the AR is 140.116. So what you do is, percentage multiplied by the isotopic mass. It's going to be 0.185 divided by 100 multiplied by 135.907 plus percentage multiplied by this thing. It's going to be 0.251 divided by 100 multiplied by 137.906 plus and so on. It just continues. 88.45 divided by 100 into 139.905. And the last one is 11.114% over 100, and that would be multiplied by X because I don't know what the mass is. So all I need to do is, I mean, it's a pretty lengthy calculation. So all I need to do now is I need to find X. What is X? The first thing is I'm going to get rid of the 100. Get rid of the 100. For that, I would have to multiply that by 100. And so it's a pretty lengthy calculation. You have to be very careful with this. When you're trying to calculate, it's going to be 10 into 140.116. And then start subtracting. Keep this on this side and take the rest on the other side. So it's going to be minus 0.185 into 135.907 and minus 0.251 into 137.906 and minus 88.450 into 139.905 and divide the whole thing by 11.114, and that would give you X. So you can probably do it on your own. You can do it on your calculator and you'll get the value of X, which is going to be this isotopic mass. So remember the AR, how is the AR calculated? The formula for the AR is, you take the isotopic mass. And remember, the isotopic mass is not the nuclear number. The nuclear number is always a whole number. The nuclear number tells you the number of protons plus the number of neutrons. And you're counting it, so that's always a whole number. The isotopic mass is going to be very slightly different from the nuclear number because the mass value depends on accuracy of the device. So the mass of the proton is not exactly 1. It's 1.00 something. So it translates into something that is in decimals. Now, the formula is isotopic mass into the fractional percentage. So you can take the percentage divided by 100 and you keep summing this up. So this is exactly what we did over here as well. We took the isotopic mass and we multiplied it by the percentage, and one of them was X, that was the unknown. So you were able to find that. You can do the math and find what the answer is. Starting with the next one, explain the meaning of the term bond polarity. What is bond polarity? So it's bond polarity is that if you have an HCl molecule, one of the atom is more electronegative. So the electrons are kind of closer to one of the atoms, which is why the bond is going to be polar. That particular Cl is going to be slight negative, and the H over here is going to be slight. It's going to be slight positive. So the definition is that it's the unequal distribution of electrons. It's the unequal distribution of electrons in a bond due to a difference in electronegativity. Because of which, so one of the atom gets a slight negative charge, or becomes slight negative, and the other one becomes slight positive. So that's what's going on. Suggests why the boiling point of HF is much higher than the boiling points of the other halides. Now, HF has a higher boiling point. Why? Because it has hydrogen bonding. Fluorine is one of the most electronegative elements. So this one is going to be a highly polar molecule. The fluorine will be pulling the electrons very, very strongly towards itself. So it's going to be one of the most polar molecules out there because fluorine is one of the most electronegative elements. And there's another reason why the fluorine atom is going to be more polar, because fluorine has these lone pairs as well. So it's got a bunch of lone pairs. And because of those lone pairs, the negative charge is even greater. So the attraction is a lot more. So you're just going to write two things. One is that that HF has hydrogen bonds. That's one thing. And the other ones, HCl, HBr, and HI. They've got permanent dipoles, and they've got permanent dipoles only, not hydrogen bonds, plus van der Waals forces. HF also has van der Waals forces. Remember, van der Waals forces are always present. But the main difference is that HF has van der Waals forces. The other mark is going to be for the fact that hydrogen bonding is a lot stronger. So you're gonna write. One statement would be that hydrogen bonds are a lot stronger, and a lot more energy is needed, which is why they have higher boiling points. And describe the relative thermal stability of the hydrogen halides. Now, when you talk about stability, you're talking about not the intermolecular forces. You're not talking about how much does one molecule attract the other molecule. What you're talking about is how quickly will the bond break. So the thermal stability for halides, for hydrogen halides, it decreases down the group. So the bottom one is going to be less thermally stable. So the bottom one is going to be less thermally stable. The reason there's just a question. The reason there's no hydrogen bonding over here is that HCl, HBr, HI, because they're not electronegative enough. Down the group, the Cl and the Br and the I, their electronegativity decreases. So the polarity is not, it's not that polar a molecule. So hydrogen bonds are just an extreme version of what a permanent dipole is. So fluorine, oxygen, and nitrogen, these are the only ones when they're bonded to hydrogen, they form hydrogen bonds. These are not going to form hydrogen bonds. They're not going to be polar enough. Now, coming back to thermal stability, the weakest bond is this one. When you have bigger atoms, and he's asking you to explain that as well. So why is iodine so thermally unstable, HI so thermally unstable? Why does the bond break so easily? The reason it breaks very easily is that it's a bigger atom, and we are talking about iodine over here. A bigger atom is more shielded. Its nucleus is more shielded. So they're not going to attract each other's electrons that strongly. So which means there's going to be less orbital overlap. The bond length would be greater. So you'll have a greater bond length. Bigger atoms, the electrons are going to be far away. So greater bond length. And as a result, you're going to have a weaker bond. So smaller atoms are always stronger. They have stronger bonds. And the reason this is going to happen is that smaller atoms, the electrons are very close to each other. They're not very shielded. So they're going to attract each other's electrons very strongly. The orbital overlap is going to be greater for smaller atoms. And the bond length would be smaller as well. Now, the next one is the equation for the preparation of hydrogen chloride using concentrated sulfuric acid is shown. Use the Bronsted-Lowry theory. So you just have to figure out which one is an acid, which one is a base. So if you look over here, you've got a Cl-1 ion. And over here, you have HCl. So that clearly shows that the Cl-1 has gain and H+1. So who's your base? Your Cl-1, your Bronsted-Lowry base, that's Cl-1. And did he ask you to explain that? He just wanted to identify the base and the conjugate acid as well. And you have to explain your answer as well. So which one is the acid? Now he's talking about the conjugate acid. When he talks about the conjugate acid, the word conjugate basically refers to the reaction in the reverse direction. So when you're talking about conjugate acid, you're talking about who's acting as the acid in the reverse direction. Who's the one that's losing H+1? The acid is the one that loses H+1 ions. So who's the one that's losing H+1? That's going to be HCl. So in the reverse, HCl is the conjugate acid. So you need to explain this now, both of them. So you're going to talk about that in the forward reaction. The Cl-1 gains, that's what you're going to write, gains H+1 ions. And when you talk about the conjugate acid in the reverse reaction, the opposite reaction, the HCl is the one that loses H+1 ions. The HCl turns into NaCl, so it has basically lost an H+1 ion. Explain why the reaction of concentrated sulfuric acid and sodium iodide is not suitable for the preparation of HI. So the reason for that is that when you talk about iodides, chlorides, and bromides, when you move down the group, they develop this tendency to lose electrons. They become good reducing agents. So I-1 loses electrons easily. So what happens is when you react iodide with sulfuric acid, when you react I-1 with H2SO4, you don't get a displacement reaction. You don't get instead you get a redox reaction. Because the I-1 really likes to lose electrons. It really likes to lose electrons. It turns into I2, and sulfur is the one that has to get reduced. It needs to gain electrons. So it gets reduced to either sulfur or H2S or to SO2. So the +6 sulfur ends up gaining electrons, either changes to 0 or -2 or +4. So it gets reduced. So instead you get a redox reaction. And that is what you're going to state. Explain why this reaction is not suitable for the preparation of HI, because you're not going to get HI. Instead, I-1 is a good reducing agent. And it reduces H2SO4. So you don't get HI and gets oxidized to iodine. So you get iodine instead of HI. So it itself gets oxidized to form iodine. So remember this, that Cl-1, Br-1, I-1, when you move down the group, the tendency to, and you should I mean, we should revise the notes as well. So remember about group 17, that down the group, they become better reducing agents. So when you do a reaction with H2SO4, this thing comes very often. So remember the NaCl with H2SO4, you don't get a redox reaction. You just get a normal displacement reaction. And it ends up forming HCl with NaHSO4. But down the group, Br-1, I-1, they become really good reducing agents. So instead of a displacement reaction, you start getting a redox reaction, which is that you start forming I-1 starts getting oxidized to iodine. Br-1 starts getting oxidized to, it starts getting oxidized to bromine. Okay. Is this clear? Alicia, clear? Why is this clear?
Yes, sir.
Yes.
So then the next thing is,
I said the next one is let's do this one. I said this is a simple enthalpy change reaction where you have the reaction is carried out at 400. Use the data to calculate the enthalpy to calculate the overall enthalpy change of the reaction. When you're given the enthalpy change of formation, you're given the enthalpy of change of formation of HCl. The enthalpy change of formation of the elements is always 0. The enthalpy change of chlorine is an element that's also 0. The enthalpy change of formation of water is also provided. So both these values are provided. So when you're given the enthalpy change of formation of all the reactants and the products, the reaction enthalpy is basically the enthalpy of formation of the products minus the enthalpy of formation of the reactants. And this is what you're going to do. So the product is water. That's minus 242. And there are 2 of them, so that's 2. The other product is 0. And minus you're going to minus the reactants, which are 4 HCls. So that's 4 multiplied by minus 92. And the other one is 0. So the minus sign will get eventually cancelled out. And you're just going to solve for that, and you'll get the answer. We'll quickly do that. That would be minus 242 times 2. And I'm going to add plus 92 times 4. And that gives you minus 116. So overall, I'm getting an exothermic reaction. Okay, that's what we are getting. So that's an exothermic reaction. The next one is, so hold on a second. So now the next one is, state the type of catalyst used in this reaction. Explain how a catalyst is able to increase the speed. So is able to increase the speed of the rate of the chemical reaction. So what type of catalyst is used? There's a copper 2 chloride catalyst, which is a solid. The other ones are all gases. So that's a heterogeneous catalyst. That's the answer. When the catalyst has a different phase or state, it's going to be referred to as a heterogeneous catalyst. And how does it work? It reduces the activation energy. You don't have to, how a catalyst speeds up the reaction is just 1 mark. I mean, 1 mark for this, 1 mark for the other one. So you just have to write it reduces activation energy. You get more effective collisions. The frequency of collisions remains the same. You just get more successful collisions. That's it. The next one is the reaction exists in dynamic equilibrium. The reaction was repeated 1000 in the same pressure. State and explain the effect on the composition of the mixture of the equilibrium. So if you use a higher temperature, remember it's an exothermic reaction in the forward direction. We just calculated this. We calculated the enthalpy change. And this reaction over here is an exothermic reaction in the forward direction. In the reverse direction, it's going to be the opposite. It's going to be endothermic. So whenever you increase temperature, which reaction is favored? It's always the endo that's going to be speeding up, relatively speaking. So endo reaction is going to be favored. So it's going to be the backward reaction. So what will happen to the equilibrium mixture? These two will go up, their concentrations would increase, and the concentration of the products would decrease. So that's what you're going to write over here, just for 2 marks. Now we've got an equilibrium, a KC question. They're asking you to find the moles of HCl and O2 in the equilibrium mixture. For this, we would have to write the equation first. That's 4HCl plus O2. So that's a reaction, 4HCl plus O2, and I think it was forming Cl2 plus 2H2O. And I guess 2 Cl2s, just a second. So 2 Cl2s. Now that's a reaction. And so that's a reaction. How far is it's because the पिछले part के अंदर, just a second. Whenever you increase temperature, because remember this specific question, you have to be very careful. Is the question on equilibrium or is it on rate? So you have to be very specific, okay? So since the question was on equilibrium, remember the endothermic speeds up when you increase temperature, but both reactions actually speed up. Because the rule is for rate of reaction, the rule is that no matter what, the reaction will speed up, whether it's the forward or the backward. Like equilibrium states that the endo is favored. That means endo jo hai wo zyada favor hoga. It's going to speed up a lot more compared to the forward. But this particular question was only focusing on equilibrium, not on the rate. So the backward reaction speeds up. और उसने कहा था कि उनकी composition को क्या फर्क पड़ता है, ठीक है? So that's what you're going to write. So then you've got उसके बाद क्या कौन सा question ये वाला? He's saying 1.6 moles of HCl are mixed in a sealed container with 0.5 moles of O2. So you got 1.6. These are your initial moles. So 1.6 moles and 0.5 moles. These are mixed. Or मेरा नहीं ख्याल और कोई चीज है. Those are your initial moles in your container, which means that this is 0 and this is also 0. Both of them are 0 moles. And और फिर वो कह रहा है कि 0.6 moles of Cl2 and 0.6 moles of H2O are formed. So when he checked at equilibrium, he found out कि 0.6 दोनों के 0.6 moles ना they got formed. तो इसका मतलब है कि forward reaction हुआ. I mean, it was a reversible reaction, but that means कि शुरू में 0 थे और अब एकदम से 0.6 form हो गए. That indicates कि 0.6 moles इसके भी produce हुए हैं and 0.6 of this also got produced. Now that indicates that 0.6 moles are getting produced. So to produce 0.6 moles, use ratios. How much O2 would get used up? 2:1. So to produce 0.6, 0.3 moles of O2 must have reacted. And to produce 0.6, according to the ratio 2:4, 1.2 moles of HCl must have reacted. Okay, so remember the data suggests that you had 0 moles initially, and once the equilibrium had been reached, you got 0.6 moles of both of them. So that means 0.6 moles got produced as a product. There was some forward reaction. To produce 0.6, 0.3 must have reacted. To produce 0.6, 1.2 must have reacted. तो अगर 0.3 react हो गए तो पीछे कितने बचे? पीछे बचे 0.2 moles. These are the moles that are left. अच्छा इधर अगर 1.2 react हो गए तो आपके पास पीछे कितने बचे? That's 0. That's going to be 0.4 moles. So is this clear? Alicia clear है? ठीक है. अच्छा, so it's going to be 0.4 and 0.2. So you found the moles and calculate the mole fraction of Cl2, hence the partial pressure of Cl2. How do you find partial pressure? Partial pressure is, remember, for Cl2, he's asking for Cl2. Partial pressure is the mole fraction multiplied by the total pressure. यानी total pressure में ना उस particular चीज के ना कितने क्या contribution है. So the total pressure is given. That's given as it's given over here, 1.5 into 10 to the power 5 pascals. अब इक्विलिब्रियम के ऊपर ना आपके कंटेनर के अंदर ये सब कुछ पड़ा हुआ है, ये सारा पड़ा हुआ है. That's present at equilibrium. So what is the mole fraction of Cl2? तो इतने ज्यादा moles में Cl2 के जो moles है ना, that's just 0.6. So it's going to be 0.6 divided by the whole thing. So I think that's 1.8. What are the total moles? That's 1.8. So the mole fraction is कि 1.8 moles में ना Cl2 के जो moles है ना वो 0.6 है. So you multiply it by 1.5 times 10 to the power 5, and if you try and solve this, it's going to come out to be what? 0.6 divided by 1.8, and you multiply it by 1.5 E5, and that gives me 50,000 pascals. Yeah, 5 into 10 to the power 4, I think, pascals. So remember, mole fraction multiplied by the total pressure. That is how you're going to find. So that is how you're going to find the partial pressure due to Cl2. So that's what we did. Uske baad, he gave us the partial pressure, so all you have to do is plug in the values, and he even made it even easier. So just plug in the values. All you have to be careful about is your calculator. Make sure you use your calculator properly. So that's an easy one. You just plug in the values and you'll get the answer. The reaction is repeated without a catalyst. State the effect on the value of Kp. So, I mean, this part I'm just ignoring. You can kind of do it on your own. Just plug in the values and you'll get the answer. The thing that I can do is I can find the units. So it's going to be pascals squared into Pascal squared, and divide by Pascal to the power 4 into pascals. So everything, the squares get cancelled out, and it's going to be Pascal to the power -1. That is what my unit is going to be. If the reaction is repeated without a catalyst, remember, no effect. Kp will not be affected. Equilibrium constants are only affected by temperature. So they only get affected by temperature. That's it. Varna inhone affect. I mean, they're not going to get affected. Otherwise. As a question number 3. For this, I'm going to open the spider chart for organic chemistry. But I just have it over here, so I'll just 1 second. This one. I just have it over here. I'll just keep this here, and we'll just refer to this. Now, this one is bromobutane. You're having a reaction with bromobutane. Draw the displayed formula of compound P, which is what? Which is this one. So what happens when you react it with bromobutane with HCN and KCN? And this is bromobutane, and this is what's happening. So the bromine is going to get converted. I mean, bromobutane is this thing. It's got one bromobutane, that's bromine at the first one. These are all H atoms. Displayed formula indicates that you have to draw every single bond. You have to show every tiny detail, except for the 3-dimensional shape. You don't need to show the 3-dimensional shape, but you have to show all the connections. As anyways, when it reacts with KCN, the Br will go away and it's going to be replaced by CN. Show the bonds in CN. It's going to form a triple bond. So show those bonds as well. That's P. And then he says, identify the reagent conditions for reaction 1 and 2. So reaction number 1 is when you have a CN, and I'm going to open the chart. Whenever you have a nitrile, this one, whenever you have a nitrile, the nitrile gets hydrolyzed by H2SO4 and reflux or by NaOH. So there's acidic hydrolysis, there's alkaline hydrolysis. And this CN that you have, it turns into a carboxylic acid. The N breaks away and it turns into a carboxylic acid. So reaction number 1 is H2SO4 and reflux. And he's saying reaction number 2. You got a halogenoalkane, it turned into an alkene. So open the, so halogenoalkane, where's my halogenoalkane? It's over here. So how can you turn a halogenoalkane back? Here's the halogenoalkane. How can I turn that back into an alkene? It's an elimination reaction. You add NaOH, KOH, ethanolic. When you do that, it will turn back into an alkene. That's going to be an elimination reaction. So this is what's going to happen over here. It's going to be NaOH, and it's going to be ethanolic. That is what will happen in this case. And the last one is, he didn't ask for that. Draw the structure of the repeat unit of polymer of Q. So butanene is turning into a polymer Q. So I'm going to draw butanene. Butanene is double bond on the first carbon atom, and you got these hydrogens. I just don't have time to draw the hydrogen, so that's butanene. And you need to make a polymer out of it. How do you make a polymer? The first thing is anything around the double bond on the right side or left side, don't draw anything on the left side. So this H, I'm going to just bend it downwards. And don't draw anything on the right side. So I'm going to take this CH2, CH3, and I'm going to bend it downwards. So it's basically a double bond. Need reaction number 1. Which one? This one? You don't have to remember that. All you have to remember is this thing. मतलब वो इस तरह पूरी equation याद करने बैठ गए फिर तो organic कभी भी नहीं होगी. All you have to do is this thing. ठीक है? No need. It's just a nitrile turning into a carboxylic acid. नहीं उन्होंने कभी नहीं पूछा ये, ठीक है? जैसा ये oxidation की equation है. No one is going to ask you to write an equation with tolerance reagent, ठीक है? That would be impossible to remember. ठीक है? The same with nitriles. But no one is going to ask you about writing an equation of what happens in alcohol with K2Cr2O7 acidified in reflux turning into an aldehyde. They're not going to ask you for an equation for that, okay? And it's kind of impossible to actually remember the whole equation, okay? नहीं वही मैं कह रहा हूँ, no need to remember that, ठीक है? They're not going to ask you about that. वो एक दो उन्होंने एक दफा मांगी हुई थी. One was this one. Similarly, iodoform test, most reactions, they're not going to ask for the equation. The only time I remember is one equation was asked was for the iodoform test, which was this one. Can't get iodoform. Not the iodoform test, 2,4-DNPH. इसकी इक्वेशन एक दफा मांगी हुई थी, लेकिन उसको भी आप खाली यही याद कर लो, that's enough, ठीक है? मतलब there was only one time they actually asked for the 2,4-DNPH equation, the whole of it. ठीक है? Even 2,4-DNPH का जो structure है ना, वही याद रखना काफी मुश्किल है, ठीक है? So if you were to, based on history, if you were to just remember one of the equations, that's probably going to be this one, because that's, as far as I remember, that's the only one that they've ever actually asked for, ठीक है? Clear है? Equation याद करने नहीं बैठना, ठीक है? नहीं किस में? नहीं वही मैं कह रहा हूँ, उसमें पढ़ो ना, डिटेल में पढ़ना ही नहीं है. You're not supposed to remember the equations of the entire equations. ठीक है? इसका आप कर सकते हो क्योंकि इसमें कुछ है नहीं कि like for a halogen alkane, you can probably remember that because that's an easy equation, ठीक है? Not for ester की equation marks, that's an easy equation, ठीक है? Not for this. For alkaline or acidic hydrolysis, not for this. ठीक है? NH4+1 बन जाता है और ये carboxylic acid बन जाता है. But you don't have to remember the equation for this. ठीक है? तो remember, most of the cases equation को तो बाद में ही रखना है. Equation क्योंकि मतलब कोई भी question उठा लो, ठीक है? They're not asking for equations. They're just asking for what is formed. That's it. ठीक है? अगर वो एक आध मैंने बता दिया कि mechanisms का पूछ लेंगे. Remember the mechanisms. That's important. ठीक है? So anyways, the thing is that remember the mechanisms, remember what's going to happen, कि product क्या बनेगा. Don't ever try to remember the whole equation. ठीक है? इसमें बल्कि I can go through and मतलब ये वाली equations तो आसान है कि an alkene turning into alcohol, water add हो रहा है. That's, I mean, you can make that equation up yourself. ठीक है? You don't have to. K2Cr2O7 equations that are impossible to remember. ठीक है? KMNO4 equations, I mean, obviously you can't remember them. ठीक है? Even RB greener, so it's impossible to remember those equations. ये इनके mechanisms आपको आने चाहिए. SN1, SN2. So for that, by default, अगर mechanism आता है, you will know the equation as well. तो बाकियों की equations बस छोड़ दो. Even ना जो एक दफा आया हुआ है ना, ये जो कहाँ गया, ये जो 214 पेज का आया था ना, वो भी मैं कहता हूँ याद ना करो, क्योंकि आज तक एक ही दफा जिंदगी में उन्होंने पूछा है और वो 214 पेज ही याद करना काफी मुश्किल होगा. अच्छा, identify the reagents. We did that. इसका हम वो बना रहे थे, polymer. So we're going to try and make the polymer, and to make the polymer, remember double bond के right और left पे कुछ नहीं होना चाहिए. So the H over here has to be bent downwards, and this thing over here should be bent downwards as well. CH2 and CH3. और फिर इस तरह के molecules जो है ना, they'll link up with each other. So they're going to link up and वो सारे आपस में जुड़ जाएंगे, and that is how a polymer would be formed. खैर उसे repeat unit कहा था, you just put brackets around it and you'll put N over here. अच्छा, अब ये कि complete the reaction scheme to show the mechanism of 1-bromobutane, तो ये तो to produce R. Now this is nucleophilic substitution. Carbon is positive. This is slight negative. अब उसने this one is a primary halogenoalkane. Primary halogenoalkane में OH-1 अपने लोन पे लेके पहले ही पहुंच जाता है. ठीक है? It attacks it and the Br gets repelled. So the middle part is, remember, you have to draw every small thing. ठीक है? So CH3, I mean, this is CH3. This one is CH2, then another CH2. So you got C with 2 H's. There's going to be a transition state where the OH is bonding with it. And you have a Br that's breaking off. And this entire thing will have a charge of -1. फिर अगले part में बस ये Br side पे कर दो. ठीक है? That, remove that Br. And that's it. So this is your transition state. बस वो आखिरी end में ना वो OH आ जाएगा उसकी जगह, Br की जगह. Now you have butanene reacts with steam as shown to form a mixture of two structural isomers S and T. So butanene, what उससे एक major product बनता है, एक minor product बनता है. So butanene is this thing. अब water जब add होगा, it's going to have two options. It can either get attached to this H and the OH could get attached to this one. That's your major product. Major product होता है, the H likes to get attached to the carbon that's already bonded to more H atoms. That's your major product. The minor product would be the other one, that you had a double bond, butanene, and you had all these carbon atoms and H atoms. So the minor product is that the H decides to bond with the carbon over here, and the OH gets attached over here, और वो बीच में double bond खत्म हो गया. So you'll have a minor product and you'll have a major product. This is your major product. This is your minor product. Markovnikov's rule states that the H atom always likes to bond with the carbon that's already bonded to more H atoms. अच्छा फिर major product को ना वो oxides भी कर रहा है. So it's a secondary alcohol. Secondary alcohols turn into ketones. So this one would be कि जो OH यहाँ पे था ना, that will turn into a ketone. So it's a secondary alcohol. So identify the type of reaction that occurs when butanene reacts with steam. That's electrophilic addition. Alkenes always undergo electrophilic addition. फिर ये कि state what can be deduced about the structure of S from its reaction with the alkaline aqueous iodine. तो S किधर है? अच्छा वो कह रहा है alkaline aqueous iodine. What can be deduced? Alkaline aqueous iodine, ये जो मैंने sheet खोली हुई है ना, इसके अंदर ही वो है iodoform test. Alkaline aqueous iodine gives you a positive result with this thing, CH3CH and OH, if it has this structure. तो जो CH3 methyl group है, that turns into a yellow precipitate, और वो बाकी वो रह जाता है carboxylic acid. So that is alkaline aqueous iodine. So what does it prove? कि आपका जो S है, which is this one, it's got a CH3 with CHOH. तो आप इसमें बताओगे कि भाई इसके पास CH3 और CHOH वाला structure है. It is present because you're getting alkaline aqueous iodine, you're getting a positive iodoform test with it. They explain why S is the major product of the reaction with butanene with steam. So why is S the major product? Why do you have a major product in the first place? तो उसका भी इसी sheet के अंदर ना explanation भी है. And that is कि whenever you have, so the explanation is, and this is exactly what you're going to write. The explanation is whenever you have an alkene and an unsymmetric alkene, तो ये इसको water ही assume कर लेते हैं. What happens is the H has a choice. It can bond with the carbon that has more H atoms. It can bond with the carbon that has fewer H atoms. So it can bond with the carbon that has more H atoms. That's the major product. Or it can bond with the carbon atom that has fewer H atoms. दोनों cases में a different carbocation would be formed. This one would form a carbocation over here. This other carbon would become a carbocation. क्योंकि H आया उसने double bond में से electrons borrow किए. So it took electrons from the double bond, bonded with this carbon atom. So the other carbon atom became electron deficient. Either there was a double bond, H bonded with this carbon atom, took those electrons. So this carbon became a carbocation. Now this carbocation is going to be more stable. उसका आप लिखोगे carbocation has more electron donating alkyl groups. यानी ये जो carbon है ना, that's in the middle. If it's in the middle of the chain, it's surrounded by a carbon chain on the right side and a carbon chain on the left side, जिनका electron donating effect होता है. तो जिसकी वजह से ये अपने electrons और ये इसके इर्द भी electrons हैं. There are 9 of them here and there are 9 electrons on this side. So the positive charge is going to be smaller because it's surrounded by electrons. So the charge density on the carbocation decreases, making it stable. इधर क्या issue होता है कि the carbocation is right at the end. So it's not surrounded by a lot of electrons. So the positive charge is really large. When it is large, तो वो क्या करता है, वो H से electrons वापस छीन लेता है, उसको H को लेने नहीं देता electrons. So this is a very unstable carbocation. It would be very difficult to form a carbocation with a large positive charge. क्योंकि उसका positive charge इतना strong होगा कि it will pull electrons away from the H atom. So the explanation that you're going to write over here is about major and minor products is, और उधर जाके मैं थोड़ा डिटेल में भी explain कर देता हूँ कि you're going to write कि you had a double bond and it had CH2 and CH3 and there was वाटर के अंदर ना हाइड्रेशन हो रही थी, वाटर का H आके बॉन्ड कर रहा था, so the H likes to bond with this one. It will steal electrons from the double bond. The double bond would turn into a single bond, and this carbon would become electron deficient. So you're going to write that this positive carbon atom has more alkyl chains. So the carbocation has more alkyl chains. Which has an electron rating effect. So it's got electron rating effect. And if it has electron rating effect, its charge density decreases. And it is more stable. दूसरे वाले के साथ मसला है कि अगर वो H डबल बॉन्ड से इलेक्ट्रॉन्स छीन के ना इस वाले के साथ बॉन्ड कर जाता, the other H, तो होता ये कि इसका जो पॉजिटिव चार्ज होता है, this would have been very large क्योंकि it's not surrounded by large groups. So the positive charge would be relatively very large. And when it is relatively very large, वो क्या करेगा, वो उस H को इलेक्ट्रॉन लेके जाने नहीं देगा, उस H से इलेक्ट्रॉन्स वापस छीन लेगा. So the reaction would not, I mean, it would be very hard to form that carbocation in the first place because it's going to steal the electrons back from it. So which is why ये वाला carbocation जो है ना, ये आराम से फॉर्म हो जाता है. पॉजिटिव चार्ज कम होता है, ठीक है, it's smaller because it's surrounded by a lot of electrons on all sides. So the positive charge is kind of smaller. So it's not going to steal electrons away from the H back again. I said draw the skeletal formula of ST and U. So that's the next one, which is ST and U. So ये तो बना लिया था हमने. All you have to do is skeletal formula 4 carbon atoms. So I'm going to draw it over here. 4, 1, 2, 3, and 4. And over here you got a dots डाल दिया करो, ठीक है? That's a ketone. So about S, it's again 4 carbon atoms. 1, 2, 3, and there's a fourth one. And you're going to have an OH here. और फिर इसका बना लेते हैं. That's वो end पे OH है. So that's, where do I draw? ऊपर ही कर लेते हैं. As this one T. T would be again 4 carbon atoms. And इस वाले के साथ OH है. ठीक है, the one at the end. So that's the one that's going to have the OH. फिर I write an equation to represent the oxidation of S to U. ये बल्कि उसका वही आ गया कि and he's not S to U by potassium dichromate 6, but he's not asking for potassium dichromate 6. He's saying कि use O to represent the oxidizing agent. So S to U, I think it was this one. Okay. Butanol turning into butanone. So we're going to do that. So saying butanol, that's CH3, CHOH. You had CH2 and another CH3. It's reacting with K2Cr27. Usne represent that by an O, by an oxen. Turns into a ketone. That would be CH3, CO, CH2, and CH3. So it's losing hydrogens. वो oxygen के साथ मिलकर they're forming water. So you just need to balance because hydrogens come हो गए. So they reacted with the oxygen to form water molecules. All you have to do now is balance it. तो दो hydrogens मेरे ख्याल से कम हुए, H और OH. You're just left with O. So they ended up forming water, and so 2 oxygens and then 2 oxygens here. So I think it's already balanced. I mean, kind of looks balanced. The next one is there's a colorless liquid with an unpleasant odor. It reacts with methanol in the presence of an acid to produce an organic which has pleasant fruity smell. So that's a catalyst. In name we. So he's reacting it with methanol. So I'm going to just draw the whole thing. CH3 with CH2, CH2, CH2. That's 3 of them. So there are 3 of them, and then there's a carboxylic acid. So clearly you're forming an ester. It reacts with methanol. Methanol is CH3 and OH. तो क्या होगा इसका OH remove होगा, this H would be removed and they would link up, they would join up. तो basically यहाँ पे OCH3 रह जाएगा. So OCH3. And the name of this would be, it's in two parts. This side is methyl. This side is pentanoate. So the name of the molecule is going to be methyl pentanoate. और फिर उसके बाद वो कह रहे हैं student analyze the spectrum with infrared spectroscopy. The spectrum will return to identify which of the infrared spectra X, Y, or Z corresponds to V. I mean, this is V. So spectrum किधर है? So which one corresponds to V? That's what you're looking for. So first thing is, you've got carboxylic acid. Remember, it's very easy to identify, like if you have the data booklet में infrared spectroscopy में दो चीजें आपको, infrared spectroscopy is not complicated. It's just that you have to look for कहाँ पे? नहीं. So I think this is DMS. Carbon 13. This is infrared spectroscopy. So you can't really get a lot of information from infrared spectroscopy, but a few things that you can guess very clearly is serial bond O. So you got a very strong absorption at 1690 to 1700, somewhere around that range. तो यहाँ पे जाके देखो, methanol में तो serial bond O नहीं है. So methanol is the one that's going to have, here's a serial bond O, so that's definitely not methanol. इसके अंदर भी serial bond O है, so that's definitely not a methanol. ये जो बीच में रह गया ना जिसके पास serial bond O नहीं है, this one is a methanol. तो by elimination आपने पहला काम क्या करना है कि serial bond O को देखो. 1600 के ऊपर ना there's going to be a strong absorption. अब methanol के अंदर serial bond O नहीं है, ठीक है, because उसके structure में है ही नहीं. It's either a carboxylic acid or an ester. तो आपको कोई ज्यादा information नहीं मिलती. The only thing that you pretty much get from infrared spectroscopy is, one is you're able to identify serial bond O, and the other thing is OH बड़े आराम से identify होता है. अच्छा, OH carboxylic acid का जो OH है ना 2500 to 3000 strong and very broad. So we do have a carboxylic acid with us. So the strong and very broad. ये तो methanol हो गया, निकल गया. तो this must be 3000. मतलब ये वाली जो आ रहा है ना, that must be the OH from the carboxylic acid. तो सारा पता लग गया. तो basically V कौन सा है, वो आखिरी वाला है. This must be V. ठीक है, that's your V. So by elimination, you were able to figure out. You had methanol. Methanol वो था जिसके अंदर serial bond O. It didn't have serial bond O. So by just not having serial bond O, you were able to identify what methanol is. Carboxylic acid का किस्सा पता लगा कि उसके पास serial bond O होता है, plus it's got an OH of a carboxylic acid. So there's going to be a strong and broad absorption at 3000. और V फिर आखिरी वाला रह जाता है जिसके अंदर OH ही नहीं है. तो तीनों को आइडेंटिफाई कर लिया कि कौन से तीन थे. मतलब वो लेबल कर दो, उसमें बस आइडेंटिफाई कर लो कि उसके अंदर बता दो कि मेथनॉल कौन सा है. इट्स द मिडिल वन. मतलब वो जो भी चार्ट था, कौन सा चार्ट था, Y. तो what you're going to write about methanol is, why is it Y? Because no serial bond O, which means no absorption at 1600. इस रेंज में absorption नहीं होगी. फिर वो किसका पता लगा? कार्बोक्सिलिक एसिड. कार्बोक्सिलिक एसिड वाज वो आखिरी था मेरे ख्याल से Z. ये जो पेंटेनोइक एसिड है, this one. How did you figure this out? Because it was carboxylic acid. So OH in COH, you got a broad and strong absorption. around 2500 to 3000. Plus you had a serial bond over as well. So 1600 to 1700 पे भी absorption आ रही थी, ठीक है? So that's how you figure out that must be a carboxylic acid. और फिर आखिरी जो बचा ना by elimination, that's B. ठीक है? That is purely by elimination. It's just going to have serial bond O. तो वो बस आखिरी जो बचा, that's V. So that's how you're going to get 4 marks for this. And that was the last probably question for this. Faiz, is clear? Abdullah, is this clear? चले ठीक है. कितने दिन रह गए एग्जाम में?
Five days.
ठीक है. चलो ठीक है, कल भी करते हैं, ठीक है? ओके देन, टेक केयर.
Hello.